Next is question 13. I have an x squared and a y squared. One of the coefficients is positive and the other is negative. This automatically makes this the graph of a hyperbola, or the equation that represents the graph of a hyperbola. The standard form for a hyperbola has some quantity of x squared minus some quantity of y squared, or vice versa, but it equals 1 on the other side. So we're going to move our 8 first and then group these x squared and the 2x together. And that's actually a space for me to complete a square. It's not the minus sign, this one is the minus sign. And I'm only going to complete one square. Let's divide our linear coefficient by 2, square it, and add a 1 to both sides. And now let's rewrite the left-hand side. This is our perfect square trinomial. It represents the binomial x minus 1 squared minus a y squared, and that equals 9. Not quite yet standard form. We're going to divide every term by 9 so that we have a 1 here at the end. Our newest equation, the quantity x minus 1 squared divided by 9 minus y squared divided by 9 equals 1. Where is the center of this hyperbola? Our center is at positive 1, 0. Moving on to 14. I have an x squared, but not a y squared. This is another parabola. I'm going to factor out our greatest common factor for my x terms to complete the square. I'm going to move the y and the 79 to the other side. I do want the coefficient of the x squared to be positive. That's why I'm going to choose to move these two terms to the other side. So it's going to be x squared equals 4py. So let's do that. Let's kind of do two things at once. I'm going to factor out my greatest common factor. Get ready to complete a square. Subtract the y, subtract the 79, and add a position for me to place the completed square number here. Take your linear coefficient 10, divide it by 2, square it, and add the same amount to both sides. So we're going to divide by 2, that makes it a 5, square it makes it 25, but I'm not going to write 25 on this side. I've technically completed 3 squares because of the coefficient. I'm going to add 75 to represent the 3 25s I added on the left hand side. We're going to take our time and rewrite this, where there's a 3 coefficient in front of the perfect square trinomial. I'm going to combine my like terms like this, and next I'm going to factor out my greatest common factor, which is a negative 1. And this is still not considered standard form in my opinion. It should be 4py equals x squared. This 3 does not belong on this side. What I'm going to do is multiply both sides by 1/3 to cancel that 3. So our final formula would look like this. So now we have 4p, the quantity of y, equals the x squared. Where's the center / where's the vertex of this parabola? -5, -4. We call that the center. Really, we call it a vertex. Alright, 2 more to go. Question 15. I have an x squared that's negative. I have a y squared that's positive. This automatically is another hyperbola. What we're going to do is we're going to place the y squared term in front of the -9x squared term, because a hyperbola always leads with its positive squared value. I'm going to rearrange these terms. Hyperbolas always equal 1, so what I'm going to do is I'm going to add 153 to both sides. Y squared, let's factor out our greatest common factor. Now it's technically not 9. If it begins with a negative, your GCF is negative. Let's take out a -9. X squared plus 8x, leave room to complete a square. And on the other side, leave a space to complete that square. What's the value that completes the square? Divide by 2, square it, add 16 on this side. Now this negative 9 in front of the parentheses means we've actually increased the left-hand side, really decreased it, by negative 9 times 16, or negative 144. I need to subtract 144 to the right side to balance that out. Y squared minus 9 times the quantity x plus 4 squared equals 9. Finally, a hyperbola always ends with a 1 on the other side of the equation. We're going to divide everything through by 9 and finish this off. Y squared divided by 9 minus the quantity x plus 4 squared over 1 equals 1. Where's the center of this hyperbola? The center is negative 4, 0. We always take the x coordinate from the x term and the y coordinate from the y term. If there's no constant next to the y, that means its coordinate would be 0. Our last one is another parabola. How do we know this? I have one quantity that's squared and nothing else. We always like our squared quantity to be positive. So I'm going to keep the x and the 17 on the left. I'm going to move the y squared and the 8y across the equals. I'm going to add a constant to both sides to complete the square. Divide by 2, square it, and add that value to both sides. Our completed square, our perfect square trinomial, is now rewritten as a binomial square. This is technically a standard form equation. If you want to factor out a negative 1, now you know that the value of 1 represents your 4 times p. Parabolas don't have centers, they have vertices, or one vertex specifically. The location of that vertex is positive 1, positive 4. So that wraps up this section. Unfortunately, there were no ellipse exercises to practice. I might make a bonus video and include one of those just so that you can see it. That wraps this video up.